Today, every day, small cap investors visit Agoracom knowing this is the day to discover the world's next great company, to have their dreams come true. That's why I take to the open road, to find them, to tell their stories, to engage them, to bring them to life, because they want to connect with you from your office, your phone, your home, anywhere. Agoracom, find your dream.
Welcome to Beyond the Deck, a production of Agoracom in which CEOs walk through their company presentations for the benefit of shareholders to put them on an equal footing as institutional investors. With us today, glad to have him back, Bernard Tuniot, Chairman, CEO of HPQ Silicon Resources, trades on the venture exchange on the stock symbol HPQ, and for our friends in Europe on Frankfurt under UGE. Programming note, for those of you who are listening via podcast, you're not going to get a benefit of looking at the actual PowerPoint presentation, but you can definitely listen in and get great valuable information. Otherwise, get to Agoracom to watch it with the deck. For those of you who are new to the story, HPQ is in the process of becoming a vertically integrated producer and a diversified producer of silicon metals, and we're talking from metallurgical grade right up to solar grade. But what we're really talking about right now is battery grade for the lithium ion battery market. You've probably heard, for those of you new to the story, you've probably heard a lot of people make those claims for a while. HPQ is way ahead of everybody, more than just lip service. They've got two world-class technology partners with them here. We're talking about PYROGENESIS Canada, who is a global leader in plasma torch technologies, and Apollon Solar, one of the world's leaders in renewable energy. So this is a great team that's bringing silicon metal, the future of energy storage, into the light. And note for everyone at home, while everyone else is focusing on other metals, the only small cap company that we know that's dealing with silicon, and Bernard explained to you why that's so important, is HPQ Silicon. Bernard, the floor is yours. The deck is up. Walk us through it.
I'm ready for it, and I'm excited because it's really a fruition of the evolution that's been occurring since 2018, 2019. It's really coming true. So really, I'm happy to be able to tell people that silicon metal is really the future of energy storage. Typical disclaimer, please read. I've actually redone it, so some people can read it, just in case. But the key point is you have to understand is energy storage dominance, because everybody talks about it. You know, that's why Tesla stock is going through the roof, because everything's talking about it. Energy storage dominance in the 21st century is akin to controlling coal in the 19th century and oil in the 20th century. That's how big this is.
Sure.
And silicon metal is literally the future of energy storage.
And you know, I know you're going to tell us about it, but people watching or listening at home think, well, I heard it's lithium, I've heard it's graphite, I've heard it's nickel and cobalt. Why silicon? What's the science behind that?
We'll get there, but fundamentally what it is, it's silicon metal is a much better electric conductor than graphite. So if you put it in graphite batteries, as it says, it's needed to break the lithium batteries limitation. Right now, everybody gets tired. Their phone dies quickly. Their car doesn't have, the electric car doesn't have the same range that they would love to have it. The key to get that done is being able to put silicon metal, replace basically graphite in batteries with silicon metal. And we got three great quotes on page 3. I'll let people read them, but fundamentally it puts it into perspective. There was even employee number 7 at Tesla that started his own company and just focused on doing that type of material for batteries.
So it's still nanotechnologies, right? And I like that third-party validation that you put in here, because it's very important so that people at home aren't doubting. Not they have, you know, you're CEO of a small cap company and they like to see some bigger, and you've got some pretty big names here talking about why silicon is the future of energy storage. So we won't read them off.
Anybody can do a little bit of research and they'll figure it out. It's no, we're not calling this out of the blue.
Yeah.
So next one. Okay. Now, HPQ is really a silicon metal focused renewable energy company. As you said, we're working in collaboration with two world-class technical partners. What makes us different from everybody else in the industry is that we're really in the final demonstration of our unique capacity to be the lowest cost producer of advanced silicon material needed for batteries. That's what we are. A lot of other, listen, energy storage, renewable energy, everybody's going to come talking about it pretty soon.
Sure, we already are.
They are, but they're all the start. They're all at the beginning. We've been doing this for 2016, so we're much more advanced than anybody else. We're at the phase where we're actually, I just sent my deck to somebody in Asia, and he was already, what price can you sell me your nano powders? So it's just, and we're just at the beginning phase, but we're light years ahead of everybody else because everybody else has to catch up. Plus, in silicone, you can't enter it. So what is it that HPQ is really doing? Well, we're really developing two key technologies all out of the PureVap concept. The first one everybody knows about, the quartz reduction reactors. It's a new, it's a new scalable, versatile, low capex, opex, carbothermic process to make silicone metal. Yes, that's great, that's important, but I'll explain why in detail. That at this stage of our development, that's not as important as the second reactor that we're doing, which is an upgrade, which we call the silicone metal nano reactor. What that reactor allows us to do is literally to take silicone metal and make nano powders and nano wires that are really needed for the next generation of lithium batteries. So,
and if not to skip over the first part too fast about the PureVap quartz reduction reactor, but because you went a little bit fast, I want to make sure for people watching.
Hey, listen, I know how long the deck is, so I know where I'm going to be talking about it. It's the
so
introduction. It's the introduction here, George. We don't need to spend that much time. We'll get more in details later. Like if we lose time at page 4, it's going to be like 3 hours of discussion. You know how long I can talk.
Your show, my man.
Okay, so what are we doing? We're fast tracking silicone metal innovation. Our lab scale, lab scale and proof of concept tests have already been done. So this is why I'm saying we're more advanced than everybody else. We've been working at this in 2016. We've done a lot of tests. We got a fully funded pilot plan and testing program. So that part is already paid for.
Right.
Our QRR pilot plant and our PureVap nano reactor about to go live. But what we're going to do with that, okay? And if you see the order of what I'm saying, you understand the importance. Really, the first thing we want to produce is nano-scale spherical Si powders and nano Si wires for the next generation lithium batteries. That's really the key, because that's going to allow us to put the valuation on everything else we're doing. At the same time, we're going to do porous silicon wafer for solid-state lithium batteries manufacture. Just being able to do that brought us the interest of a silicon solid-state lithium battery producer, and we already signed an NDAs. We're changing discussion. We're doing a lot of discussion.
That's significant. I got to admit, that's really significant.
And as I've done discussion, as I've said before, it is our relationship with Apollon that started in 2017 also gives us a unique position. Apollon owns the patent to make porous silicone wafers out of metallurgy grade silicone metal. Okay, so it's not something we could have developed. We would have to negotiate, or we already get access to that patent. So that's already one thing that's pretty great.
And that's a huge competitive advantage, right? Because it's not as if Georgia Silicon Company can come and recreate it. You've got the license.
There's going to be a ton of companies. There's going to be a ton of companies. There's going to be a ton of people out there who are going to try to say, I have a quartz deposit, ergo I'm in the silicone business and I can do this. It's not that simple. It's far from it. I'll explain more in detail why.
Right.
But in this regard, if you want to say you want to make porous silicone wafers, okay, basically anodize them, starting from metallurgy grade silicone metal, there's one company that owns the patent, that's Apollon. It's just going to be the one company with the PureVap. It's going to be us. That's what it is. But since we've been working with them, and their usage for that technology was something pretty cool in hydrogen area, but still, for us to be able to use in the battery space is great. Third thing is we've discovered is you can take those high purity, those basically porous silicone wafers. You make them so porous that they're very fragile. You just crush them, and that becomes a high purity porous silicone metal powders that is already being used right now in the lithium ion batteries. Like it's about 5% per weight in a mix of graphite. They're already using this, and that's already an addressable market. It is not the same market as the one I talked before. The nanoscale spherical Si powder is one where we're looking at replacing. So the addressable market for that one is the equivalent to the graphite one for batteries.
Got it.
This one is already a market. It's going to be $1 billion by 2022. And the last market that we're looking at is basically our QRR's ability to make, metallurgic grade silicon metal cheaper than everybody else. I'll explain later why I'm not putting that much of an emphasis on that, and people will figure it out, but I think it's clear in the presentation. Next one.
Yeah, if I can guess from now, it's probably because not a high value product as the other one. So, but anyways, that's just my guess.
Yeah, but that's pretty cool. This one, page 6, I'll let you guys read it. I won't go through one by one. I've sort of said that. It's another way of presenting everything I've said.
So everyone at home should pause, at some point after the presentation, come back to this page and go through this great summary, this great overview of where the company is. It's a great overview. Sometimes a deck is made to be presented. Sometimes there's, you want material to be there. That's one of those. Let's go to what silicon metal really is, because nobody knows it exists, yet it's one of those material that's needed in everything we do in life. So it's even described as a key strategic mineral by the European Commission and the US Department of Justice. It is needed for the renewable energy transition. So whenever you hear renewable energy, silicon will be into it. The usage are massive. Aluminum, okay? That's the metallurgic grade. That's what makes the car stronger. The aluminum's stronger, so you can use it to replace steel to build lighter cars, to basically either consume less or electric vehicle. Right. It's used to make silicones. Everything that's silicone based is made out of silicon metal. That's also very needed in renewable energy, because you need that silicone. It's the only glue that you can seal all the things from the water damage and everything else. As I've spoken massively, it's also used in the solar business as the feedstock to make the solar grade silicon metal. So that's where it is. You see the global megatrend on the next part of the presentation, okay? But the key point to remember is that silicon metal does not exist in its pure state. It has to be manufactured.
It has to be manufactured. You cannot be a mine of, you cannot say you're a mine of silicon metal. Having a quartz deposit does not make you a silicon metal player. If you're saying that, you are pushing the truth. Okay.
And by the way, if I can also mention something that I really love about it, and maybe people have just figured out, because you don't have to dig the silicon out and go to the traditional mining process, you pretty much step right over the whole investment hurdle that most small cap juniors run into, which is, okay, we got this great resource, we can use it for batteries, but we need $500 million in order to get it out of the ground. You don't have.
Yeah, but that's literally whatsoever. Specific. That's specific to our process and our way of doing this. It's what differentiates us. And as you go through the presentation, I'll explain to you even where we are better at this. So, So the fun part about quartz is basically it's the most abundant minerals, but the process to make silicon metal is really an expensive carbothermic process needed to extract it. You have all the global megatrend. I think we've said them over and over, but basically renewable energy and alternative energies is really a key factor.
And when you say expensive carbothermic process, expensive obviously speaks for itself. Carbothermic in layman's terms also means it's a dirty process. It requires a lot of carbon at the end of the day for the tradition.
It's not really dirty per se. Okay, it's just that it requires carbon to extract. It's part of the concept of using carbon. But you know, it can be done well. Carbothermic is not a dirty word per se. It's just an expression of what the chemical, the process is.
Okay.
Next slide. Silicon metal demand outlook. This is a key thing that you have to understand, because that's the basis. That's what differentiates us, is that we will always have that unique opportunity to be the lowest cost producer of our raw material. But where we are in the value cycle of doing things, that's not our biggest advantage. But we have this, and that's what get us where it is. Standard silicon metals, 98.5 to 99.5 SI. Okay,
purity. That's a purity level.
That's a purity level. What's unique about our PureVap process is we're the only process in the world that can take raw material, because I'll explain later, that can take raw material of a certain purity and have a final product that's a high purity. All the traditional processes require massive high purity material, which is what makes them very difficult and complicated for them. They need high purity quartz, high purity low ash carbon and wood chips, and an electric furnace to make 98%, 99.5. So you have to start with higher to lower, okay? Our process can start from lower to go to higher. We're the only one that can do this. Why is that significant? Well, right now, worldwide demand for silicon metal is about $2.8 million, worth about $7.5 billion in 2018. It's projected to increase by 1 million ton to 3.8 in 2023, worth $12 billion.
That's pretty fast growth for.
Yeah, but that's pretty fast growth. But the issue is for the industry, okay, is that what's driving that demand is chemical sector, okay? 2N plus, base and electric vehicle growth. That's what's driving that demand. Fundamental problem with conventional process limitation is they can only about 40% of a plant output, okay, can make 2N. For us, it's 100% that's going to come out that's going to be about that. So that's already one of our advantage.
Wow.
So that gives us, at the end, when we're going to be fighting for the last profit, we're always going to be winning. But at the beginning, our process, and we've proven that, we've demonstrated that with many of the testers. Next point. So to meet the anticipated demand, as you said, the 1 million ton, new plants will be built. Well, what are the barriers to entry to building those new plants? Okay. Traditional process, conventional plants, they have a minimum size requirement of 30,000 metric ton per year. MT is a metric ton. I was asked that question, never had time to reply. Sure. MT means metric ton. The capital investments are through the roof. There are two last greenfield plant that were built cost between $220 million and $300 million. Okay. The difference in cost is one of them was a new player in the silicon metal. So what you do is basically you buy a turnkey project, more expensive. And the other one was built by a top tier producer, Rima, in the US. So they knew how to build them in. So it's only cost them $220 million. So you look at the CapEx, it's $6.11 CapEx per kilogram of annual capacity.
And it has to have a minimum, and that's because they're required to have a minimum size requirement of 30,000 metric tons. So in a lot of ways, what you're doing to the manufacturing of silicon in a lot of ways is what happened to the manufacturing of computers back in the 60s. Yeah. You could only build one size computer, a big, massive supercomputer that required rooms to fill it. But then along came Apple and IBM and others who were able to say, hey, I can give you the same computing power, but with much less requirement for, I guess, space, size and space. I know it's very layman and rudimentary, but just to
it's a concept as we can democratize, basically allow more people to enter the field of silicon metal and go more specifically. But right now we control that. You know, it's only us that have this, and that's our objective is only to use it for our own greedy advantages.
What's your minimum size requirement? Is 30? If it's 30,000 metric tons for the world,
George, no need to go rush. It's covered in the presentation. Let's go through the steps. Let's not be early. Take our time. Breathe. Conventional processes. That's the other point I want to go. I don't want to talk to you about my process. Conventional process have other limitations. 90% of their costs are almost similar. There's no price difference. There's no efficiency difference. It's only energy cost that plays into it. Okay. And one of the biggest problems is that energy companies are smart. They force them to get cheap price. They're obligated to pay for the material. So even when they shut down their production, they have to pay for the electricity. So that screws up their entire system because it's big. Because 30,000 ton requires a lot of voltage. So 90% of all the conventional costs is in a tight bracket between $1,400 to $2,000 a metric ton. It requires 6 metric tons of raw material. Make the math what's required for you to start a plant. 30,000 ton per year for 10 years, multiplied by 6. That's how much material you need. That's a lot of CapEx that's required there.
Wow. Yep.
Raw material, electricity, depreciation, CapEx, bulk of the cost, 80%. There's no really, there's no between George and Bernard's traditional silicon metal plant.
So the big guys are all really expensive, it's a question, inefficient, and they have small differences between them at the end of the day.
At the end, they play on marginal differences on their own scale and how they can play around with their system. And since it's bigger scale, you can reduce the cost. So fundamentally, it's an industry where the biggest guy wins because he has the advantage of scale. Okay, so that's why that was a massive barrier to entry. Second problem they have, not us, they do. There's a strategical risk. The largest cost raw material is low ash coal, and half of the worldwide supply is controlled by one of your competitor. How are you going to enter that business? If that's the case. That's not my case.
That's
the
crazy.
case for the same. So I'm just saying this is a situation.
Yep.
The silicone metal, it's a nice market. Okay, it's not overly sexy, but it's a beautiful market. New plants are needed to meet demand. Massive capex and investment, and you're basically got to negotiate with your competitor to get the low ash coal. Fun situation to be in.
Yeah, I wouldn't want to be investing $300 million into a plant, then have to go to one of my competitors who controls half of the input
that's what it is.
That would be a no-go.
So here we go. What's our proprietary solution? The PureVap is a scalable, versatile, adaptable process. That's what I've been saying for a long time. It's, we scale it by an instrument of 2,500 metric ton, maximum size per reactor. Okay, and we only need quartz, carbon, our process, and we can make up to 4N. We've demonstrated using 98.8 SiO2, which is like nobody can do that, and we've made 99.99 Si. And based on all our calculation with the same raw material, we should have been able to make 4N at the Gen 3. But okay, that's where it is. So we have a low capex. Okay, we're very competitive versus traditional process. We're much smaller. So basically, the same price as a tier 1 competitor. We need 85 to 90% to start our production. So with 2 reactors together, we're the same price as Rima that needs 30,000 ton. What that means is basically for 5,000 ton a year, even if it's a high value market, it's not going to change the needle for $1 billion company, but it's going to be very important for us. So we're perfectly designed for where we are going. We've already demonstrated, we already know that there's enough quartz and enough carbon for us because we can use lower source. So we don't need the mine. That's not a big part of the issues for us because our size plant is also not very big. So we're very different for everything else. So this is the solution. If we take a look at this one, and this one explains why, although I'm very excited about the technical capacity and what the PureVap QRR can do, okay? This graph shows to everybody why this is a high volume, low margin market. So to be truly, to truly take advantage of the PureVap QRR business, we got to develop a high value, low volume business, because that's where we're really going to gain the advantage over everybody else.
Okay.
Eventually, as it gets bigger, we'll be able to take it. So if you take a look, this is for the lowest grade. This is for metallurgic grade silicon metal. You have the U.S. spot price, you have the cost of everybody else, and you see where we are. So fundamentally, however the price varied, we would always have made money. But we're talking about what? We're talking about peanuts. It's not really peanuts, but we're talking about what, $1,000 a ton. So that's a volume business. Okay.
So the difference between for everyone watching home, the difference between the light blue and the dark blue, almost purple, that's basically their margin at the end of the day, because the costs are so high and the price, they're so competitive that they're getting squeezed on margin at the end of the day. Whereas you're at below the white line, basically. I'm below,
I'm below there. I'm at the between 1,000 to 1,500. So I'm like, I'll get to win, and this becomes very important where it is, and it would have been maintained to have been very, very strategically important if our focus was to remain onto the solar business, okay? Because that would have given us an advantage over any other solar producer, but only would have given us a $2 advantage, which is big, but still. So for a junior company our size, we're much better to focus on the ultra high value market than the lower one. So that's the point I want to say. QRR pilot plant would be just demonstrating this. This is fun. This is interesting. This is great. But if you truly understand what we're doing and what we're going to be doing in the battery space, which I'll try, hopefully convey in the balance of the deck presentation, you'll realize why our strategy to focus on the nano reactor is much more important. So basically, silicon metal is already part of the EV supply chain. And I'd like people to pay attention. The estimate for year is 2030. It's just the same one I've had in the presentation for a long time. The only thing that changed is the number of vehicles. Up to not long ago, the number of vehicle estimates for 2030 were 24 million vehicles. We're now talking about 54 million vehicles.
So that's that bar at the bottom, 54 in 2030 versus 566,000 in 2015.
But the numbers that we had in projection 2 years ago for 2030 were 20 million. That's the point I'm saying. EV demand is going through the roof. That's why Tesla is going through the roof. It's because renewable energy is where everything is going, and there's massive, basically, bottleneck, and this is what we're going after. We're going one after a very specific one, which is the silicon metal, which can really be important. So what we're doing, we're focusing only on the high market value, which is energy storage. And we're incredibly well positioned because we're not just a one-hit wonder to make this work, okay? Working with Pyro, we're developing what I said, the nano reactor, which puts us in the spherical nano SI powders and nano wires. That is a product that is designed to replace graphite in the battery space.
A lot of graphite guys aren't going to want to hear that, that's for sure.
Not my problem. Like, it's in the transition phase, there'll be mixed graphite silicone product into it, okay? But that is the product that's out there. Second thing that we're doing is we're working with Apollon Solar, okay, where we're combining our ability to make low-cost silicon metal with their technology to make porous silicon wafers. In one sense, to make the literally porous silicon wafer for solid-state lithium-ion batteries. And the second thing is to see if we can basically quickly figure a way to crush them, make a product that people are already using it in the industry, and start generating revenues out of this. So those are, if you look about it, and nanowires are so in demand that the price for nanowires is so astronomical, it's only specialty government program that afford it, okay? There's one company that does them, and their client is Airbus for a military contract for space satellite. So, you know, if we come up with a low cost type of thing, it's going to drive people completely.
And when you mean low cost, so what would be? I know you're not going to give us pricing
I'm
here.
not going to give specific for two reasons. It says, you know, I know how cheap I want to make it for. I know what the industry is willing to pay. Okay. But if they're going to willing to pay 10 times more than I'm willing to sell them at, I won't tell them that I can do that. I'll just take the 10 times. And when somebody tries to undercut me, I'll just keep undercutting.
Yeah, and they're limited. They're limited to how far down they can go, because we saw that in the chart before, on the graph before.
That's one area. But on the silicon side, one of the big thing that differentiates me is that we're working fundamentally from metallurgy grade silicon metal. All the work that's been done on the nano powders, everything else comes out of using electronic grade silicon metal. So if anything, people understand, solar grade is difficult, is expensive. Electronic is even more expensive to do. Metallurgic, as you see, is very cheap. So the price difference is massive. So this is what we're focused on. This is what, this is what's going to give us, long-term staying value as a company, as a project. And it's going to give us also value into the market, because that's what the market's looking for.
And for new people watching, are you years away? Because these sound like really sci-fi names. I know the current shareholders know the ballpark, but for new people who are watching and listening, how far away are you from making silicon metal nano powders and porous silicon metal wafers?
Much more advanced than people think. Porous silicon wafers, we're going to have our first one shipped to laboratories to do preliminary testing. We're still working with the battery manufacturers to get the final, qualification, how we have to build it for them. For the nano powder, we're as soon as we have the Gen 2 the Gen 2 converted, upgraded really to the nano reactor, we'll start producing. Because in this field, you don't need a batch of 2 tons for people to approve your material. Small quantities is done, approved, and everything else. Then you can focus on moving forward. So that's really what it is.
So you're talking a timeline of several months. You're not years away from this.
Bernard, months.
Okay.
So I will not dare to say the word imminent, but we're much closer than anybody else can be. Let's put this in perspective, okay? Yep. Everybody else isn't thinking commercial scale. We're already there, or we're already demonstrating this. This is what we're going to do. Because if we demonstrate we can do it with the Gen 2 PureVap nano reactor, then we already know how we can update the pilot plant to make powder. Once we got this down, then it's a question: do we, depending how big the market is, the selling price that we get for it, do we just replicate the pilot plant, do multiple of them, so we have a few of them working together, start generating quantity before we move up to a bigger one? Those are all the numbers will become clear as we move forward, but we know target range we want to be. We know the price the industry is willing to pay. And I think the next slide is going to help that go through. So silicon metal is literally the graphite killer for lithium ion battery. Now, this is slides people not going to like in the graphite space. As I said, silicon metal is a little greater energy storage capability, well, for smaller batteries, for electronic device and electric car. It's going to reshape, as I said, it's part of the key point. It's going to reshape the global economic around the way electricity is being used, stored, and deployed. So silicon metal can increase battery charge by 10%. And energy density.
Wait, hold on. You just said by 10%. You mean by 10 times?
10 times, yes. I keep sorry. 10 times. No, you're right. You've caught that one. It was just a test. Test, see if you were listening.
So silicon can increase battery charge by 10 times over graphite.
Yeah. And
wow.
In the next slide, we'll go more into a bit more detail. Yeah, this is what I'm saying. Massive energy storage demand is coming. This is a graph. This is something you've probably seen in graphite company. I'll be very brilliant and just copy them. The impacts on raw material, everybody knows it's going to be massive. Okay, but presently graphite is a low energy density material, is the principal ingredient. Even Mr. Musk says, it's not a lithium battery, it's a graphite battery with some lithium into it. But look at the energy density. Graphite, 1,200 watts per kilogram. Silicon metal,
where are we looking here? Just guide us here. Where are we looking?
Well, just energy density of anode material. It's very simple. You know the 3 bars.
Got it. Okay. I was looking at the graph on the right-hand side.
No. We'll take care of what's on the left, and we'll take care of what's on the right.
Got it.
So basically, energy density of anode material. Graphite, 1,200 watt hours per kilogram. Silicon, 6,000. Lithium, 7,400. We're pretty close to lithium. If there was a way to make a full, an only silicon batteries, it wouldn't be that bad. But, it's a mixture. So graphite used in lithium ion sells for about $10 a kilogram. That's a high value product for graphite manufacturers. That's what it is. Energy storage and EV demand cannot be met until silicon metal replaces graphite one. So we're talking here about substituting graphite anode with silicon metal one represents a massive opportunity. What the graph on the other side tells you, okay, is how many tons are going to be required of graphite, everything else. That translates to an addressable market for graphite in 2018 of 3.4 billion. It's projected to increase to 14 billion in 2023 and 24 billion in 2028. So I understand why graphite guys are all excited. But remember, they got to go and get mines and everything else. Now, you replace graphite with silicon, nano silicon powder. The quantity of material you need is cut by 10 times because
right.
10 times. But the dollar value that the people are willing to pay is the same one. So we're talking about an addressable market for this is still $24 billion. It's massive. And it's not sci-fi. Spherical Si nanopowders and nanowires have been identified. They actually work. The reason why people are not using them, manufacturing nanopowder is not yet commercially feasible. That's why it sells for $30,000 a kilogram.
Holy moly.
The target price that you have to do, you take that 10 kilogram, multiply it, I hear numbers from 10 to 20 kilogram, okay? So I took the 10 one for the addressable market. So you multiply it by 10 times, okay? That's how much battery manufacturers are willing to pay for substitution. So you're talking about $100 to $200 a kilogram. It's massive, but it's selling for $30,000. That's a heck of a price drop. Now, we think we could reach that goal very economically. So that's what we feel very comfortable with. This is why I think where the market is. So addressable market for this, massive. Why? Well, basically, PYROVAP nanoreactors, new proprietary process. There is a provisional patent that's been filed. It's a way to make them. We've demonstrated we've done. So you see what we've done. Those are simple. And pretty soon, the coming months, our Gen 2 is going to be converted, or upgraded. I should have said upgrade. But anyway, it's converted into a commercial scalability SI nanoreactor.
And for people at home, your Gen 2, up until a couple months ago, was just, all right, Generation 2, you're pretty much going to mothball it because you're going to move on to your Gen 3 pilot plant. But now you've actually found use for the Gen 2, which is pretty amazing.
Well, but it's going to do the same thing it did before. It's going to validate the process, allow us, well, it's going to do something that we couldn't do with the Gen 2 for solar. Because the Gen 2, because of its size, we couldn't get the maximum purity. Okay, so this is why the pilot plant was really important if we were still in solar. But now we just want to produce nanopowders, demonstrate we can produce nanopowders, get an idea what's going to be our yield, our production yield, and everything else, what's going to be our costing, and then figure out how to go and sell it and present it to people. So it's a completely different thinking. What you also have to realize is what incredible flexibility we have in feedstock, as we did with the QRR, where we didn't need our own quartz mine. Now we can either use our own internal feedstock if that's the best economics, or we can just go buy metallurgical grade silicon metal. So that saves us all the hassle. We just buy what we need. Or if we want to be ultra green and ultra environmental, we could actually go get recycled solar panels, because solar panels have a life cycle, 30 years. Right. Okay, so there's going to be solar panels coming back, being recycled. That's going to become an issue. We can take those, crush them, put them in a pure evap reactor, which has the capacity to eliminate impurities. And then from then on, we'll be able to use that to make the feedstock for the next generation of lithium-ion batteries.
So you can take, you don't need top-end feedstock.
No, because we keep the pure evap ability to remove impurity. So by keeping that capacity within the system, there we are. And the end product we're going to do is spherical nanopowders in nanopowder silicon metal. So if you go to the next slide, it really shows it. We've done a proof of concept test. Okay. And the fact you have perfectly spherical, I won't get into too much detail, but it's really what's required in the battery space, because you need a material that is easy to squish into the tight, because it's really a paste. You print the paste into it, and that's how it's done. So that's really a strength. We're pretty close to the size of, actually, depending on who you listen to. According to the professor we worked for, we're in the right size ballpark that we're looking for to making them. And remember, this was a proof of concept test with the pure evap when it wasn't working as we were designing to do. Okay, and it worked.
Wow.
So this is why I'm saying it's like, and remember, the engineers of Pyro understand the pure evap system like nobody else. Understand the technology of making nanopowders like nobody else. They invented the one for titanium. It's a match made in heaven. It only took me 2 years to convince them to do it, but still, it's timing is perfect now. And you see the image. Those are spherical nanopowders. Those are nanowires. I can tell you, I was talking to somebody today, and he said, when can you deliver me samples? Let me at least start the podcast.
I wish I could ask you more about that. Can I?
But it's just one of those, the conversation's just starting because it's out there. If you go take a look, if you Google images of spherical nanopowders, there's not too many of them. We have some. But it's all done at that's why it costs $30,000 a kilogram. The reason why we know it costs $30,000 a kilogram is we ended up buying some, just to see how it looks compared to what we're looking to do. That's the price we ended up paying. Okay, you pay per gram, but still. So this is what we're aiming for. This is a high value market. Presently, it's very expensive to make all through the traditional process. We're looking at making it much cheaper, and it's a new process that we've invented that expands on our pure evap technology in partnership with PYROGENESIS. So everybody knows about PYROGENESIS.
Yeah, and let's talk about. Not everyone knows because there got a lot of new people watching. Let's talk about why it's so important that you have two world-class technology companies, and let's talk a little bit about their capability. Because when we say world-class technology, we're not just throwing that around. You're going to go through PYROGENESIS here, who you refer to as Pyro throughout and then Apollon. So take us through why
it's
globally renowned.
They're really, they're plasma expert. And fundamentally, the pure evap process is a submerged arc plasma in vacuum. That's the short version of it. That's really what it is. So we're within their level of expertise. They're the number one expertise. They've also invented plasma atomization for making spherical metal powder. And now we're moving into the metal nanopowders, but the metal silicone metal nanopowders, even though, you know, silicone metal is not really a metal, but still. They have a production plant. They work for the U.S. Navy on many contracts. They've just got a massive contract for Drossrite system, which is basically it's a green tech. It's an advanced green tech using base out of plasma. The advantage for HPQ is that they have over 70 employees with tons of PhD, #1 expert. There's no way that a company the size of HPQ could have built that type of technical team.
No, and let me just say for everyone at home, their technology is used on the last 2 U.S. aircraft carriers built, and they've already announced that their technology can be used on the next 2 U.S. aircraft carriers built imminently. So that should tell everyone at home that this is a world-class technology company, because you don't get your technology onto an aircraft carrier of the U.S. Navy without going through the most rigorous of rigorous, you know, testing and validation. So that alone tells you how world-renowned they are. So if they're dealing with, you know, if they're working on with you now on silicon, that obviously says a lot about what they believe.
Okay, and that page where I told people to read into it, one of the key points that people have to understand is Pyro is not only we outsource R&D to them, they're also our largest individual shareholder. So we really are, and in the nanopowder, as we've announced, we've looked into doing a joint venture, because it's really taking our PureVap technology, combining with their expertise in powders and working together. So PYROGENESIS is more than just a contract person who works for us. It's really our partnership. We're basically pushing in the silicone metal space their expertise, and that gives us a unique advantage. So, you know, it's pretty cool.
Beyond pretty cool.
Yeah, and Apollon Solar is a French engineering and R&D company fully dedicated to the field of renewable energy, okay? It was created in 2001 by a team of engineers that were understanding the problems of silicone purification and everything else. So they have a massive knowledge of everything. They own 23 patents, including one, which is a key one, for manufacturing porous silicone wafer from metallurgy grade silicone metal. In the solar space, they've demonstrated that basically metallurgically produced solar grade silicon metal could match the efficiency of solar grade silicon metal produced by a polysilicon process. Okay, so that's really cool. But and this one really explains it's globally renowned. Apple has a strong background in the silicon process. You can see what they've been doing. They work with so at the beginning they were mostly working on cost reduction for the solar industry. But since 2011, they've been working on new market, high value, just like we are. They're engineering firms and everything else. They have the patent in 2012 for the porous silicone production. And since 2017, we've been working together. And now we were collaborating on silicone for the solar space, but now we're much more on porous silicone for storage. We're really focused now on the storage part of the business. So this is where it really is, you know, the low cost production of porous silicone metal for batteries. So what you have is our PureVap QRR to produce the silicone. Then you go through the steps, crystallization, you do wafers, and then you go through anodization. That's what they own the patent on. You produce porous silicone Si wafers. So we're going to be using them with a solid state lithium battery producer. That's what we're working on, you know, fine tuning the production and doing it for them. But we're also at the same time going to take some of those wafers, crush them, and use them as porous Si powders for lithium batteries. What the process flow should tell you is the process flow between PureVap and anodization is fundamentally based on equipment and process developed for the solar industry. So it's off the rack process, nothing really technically challenging to do. And presently, silicon metal powder are used in blended with graphite for lithium ion batteries, resulting in 5%. You know, it's about 5% per weight, as I say. But still, the silicon metal powder demand in lithium batteries is going to be increasing year over year by 43.6% between 2016 and 2022. It's going to be a $1 billion market. So this is a $1 billion market. It's a blue sky market for solid state lithium ion batteries, because if that pans out at work, it's going to be massive, the demand. Replacing graphite is a multi-billion, and these are all high value products. So I think we're pretty darn well positioned. I'll go through a bit through the solar thing just to finish it, because that's really what it is, and that's what we started at it. But solar grade silicon metal is a large, yes, it's a large and growing market, but it's a high volume, low margin. It's a really a high capex industry.
That's a commodity business.
It's really a commodity business, and the Chinese have really taken control of the industry by controlling the part where they make the wafers. So the scales you would need are of the scale of the Nemaska lithium, or those type of scale you would need investment in. Doesn't fit for a company our size. So that was just our technologies for people to remind. We didn't forget where we came from, but all the work we've done through here, okay, is what gives us the incredible advantage of everybody else. Remember that nobody's going to be able to come into the business without going through those learning steps. So this is the legacy process for people to realize. Key point is the traditional process are bad, but sometimes that's the process that is winning into it. Even though
I like this graphic because it kind of gives you an idea of
well, that's another thing that's going to happen.
How good of a carbon footprint you have compared to everybody else.
Yes, and it's the same. We're going to have probably the same, even better carbon footprint for the nano powders and everything else. Fundamentally, the raw ingredient, really, one of the raw ingredients in making any of those type of silicone product is electricity. So, however you end up producing your electricity plays a big role on your carbon footprint. So our process being in Quebec, will have cheap electricity, we'll have green electricity. So we'll always have the best carbon footprint of any type of silicone material we do. That is for sure. So those are really the key points. What's the potential? Basically, as I said, 2016, 2019, we did successful Gen 1, Gen 2 bench testing. That really validated our process work, that our pure VAP concept works of being able to convert quartz into silicone and remove impurity from that silicone metal. So the Gen 3 QR pilot plant and the Gen 2 SR are going to be operational in 2020. Why I say this? Because I mixed them both into them. For me, they're
so that answers my question. They're going to be right. Okay.
Yeah. And what we're going to be doing in the same time is we're looking at sale potential offtake agreement in 2020. So we're going to send material. We're going to do that. That's what we're going to do with everything else. And we're already in discussion with solid state lithium ion batteries and everything else. So we have multiple outlets as a moment where demand is going to go through it. I understand how the industry is. It's going to be whenever you start being able to produce a independently validated, this is why we signed we've issued a press release about the work we're doing with the university professor. So once we start having those type of results out in public, and they'll be coming hopefully soon, because we have a batch of other things we've been working on that we want to announce, but it's contingent of us filing a provisional patent for another process. It's like we've been very busy in the battery space, very, very busy. So in 2018, we closed a $5.2 million government. So the Quebec government is involved into this, $1.8 million. And at that time, it was only the QR for solar. Since then, the Quebec government has basically chosen that they're not going to focus too much on the solar part of the business. They're going to focus more on the energy storage part of the business. So it's fantastic that this is not where we are. So we're going to be able to continue our discussion. They're going to create, they want to put a lot of money into developing this, and we're more advanced than everybody else. So it's perfectly positioned. As I said, PYROGENESIS Canada is one of our largest shareholders. They invested $1.95 million at 12 cents in 2018.
And that's always a pretty big, that's when you've got your technology partner, who's also one of your biggest investors. That speaks multiples of the confidence they have in what the company's embarking on here. Yes, and
what's interesting is, as we have evolved, because we've been working with them in 2015, as it evolved, the potential has grown, the vision behind this has grown to a point where we didn't foresee it at the beginning as being that massive. So we're pretty excited. PYROGENESIS is very excited. So everybody's very. We're in the right space at the right time.
It sure looks like it. That's for sure, with the right partners.
Yeah. So why invest in HPQ? That's the key question. Okay. UBS estimates that over the next 10 years, the energy storage market in the US could grow to as much as $426 billion. More
Wow.
And I love what the guy says.
Wow.
And there are many ways to buy into the surge. What's Tesla going through? Okay.
Yeah.
Well, HPQ silicone is an investment opportunity to participate in that surge. As people are going to start figuring out that it is not my QRR that's going to be used, it's the fact that I am in the energy storage place. I am more advanced than most people can even figure out. All right. There's going to be 50 people trying to copy what we're doing, but you can't. First of all, there's only one Pyro.
Yeah, they don't have the technology partners.
They
It's
don't
not
have
like
the
you're
technology
just
partner.
throw
And
stuff on the wall to see what sticks. You've got technology partners that had knowledge, years of knowledge that George Silicon can suddenly pick up and say, "This is a good business. I'm going to get into the silicon business."
and remember, silicone metal is not a mine. If somebody tells you he has a quartz mine, therefore he's in the silicone business, Pinocchio.
Long way to go from raw quartz to get it to the kind of silicon that you're producing at the end of the this from metallurgical grade up to solar and nano powder in between.
The key point that's been happening with HPQ is we had a little bit of excitement in 2016, 17, because we were in the solar space and people thought the solar space was exciting. We thought it was exciting, but really what we were most excited at the beginning was the PureVap work in removing impurities. That we knew was a key part. We've worked at it, we've developed it, and now we knew that the silicone for battery was an important part, but it suddenly took off. Like the projection are going through the roof. When we started this and talking about electric vehicle cars, we're talking about $20 million vehicle in 2030. Goes to 54 million. You have a clue how much that changed the demand of everything else? Now suddenly massive amount of money is pouring into this because everybody wants to be into it. Everybody wants to be into green technology and everything else. Doesn't matter if you believe or don't believe it, it's irrelevant. This is where the industry is going. This is where the world wants to go. Energy storage, high efficiency batteries, and silicone is the material to it. You took a look at that little pink thing that two people see it. Silicone is 6,000 kilowatt per, and lithium is 7,006. Graphite is less than 1,000. It shows you that silicone is one of the key ingredients of it, and we're perfectly positioned. We're going to have our pilot plant operational and our basically our SI-NR reactor test about to go live. Okay. Now, why do I say about to go live? I'm going to be very simple. We're not reproducing the machines. Okay. If I was copying and pasting the machine, I could give you exact timeline of when everything's going to be done. We are creating those machines. We have 4 years of working at it, so we know a good idea where we're going. So I'm going to leave the timeline a bit loosey, but that's okay. But we're ready to start commercializing the following program: nanoscale spherical SI powder. I'm telling you, it's literally out of the blue. Somebody contacted me and we started to exchange. And when he saw I sent him a copy of the deck. He saw the deck, says, "When can you send me nano samples yet?" I didn't even know that guy.
Yeah, that's pretty powerful.
Now, I knew who he was, and I know where he works for. Like he's pretty big in the silicone business in Asia.
So we're on the radar at the end of the day.
We're starting to be
getting onto the radar.
We're getting on the radar.
Right.
Okay. We're just getting on the radar. But then the goal now for us is to go out and say, market, this is where we are. So basically, HPQ is an investment opportunity to participate in the search. That's what HPQ is. It was always into the renewable space, but now it's much more specific to the energy storage space. So we're going to be commercializing our PureVap-based product, nanoscale spherical SI powders and nanowires, porous silicone wafers for solid-state lithium-ion batteries. Remember, guys, we're under an NDA with a solid-state lithium-ion battery manufacturer. So what that means is we're working together with them in Apollon to figure out how we can meet what they're looking for. We believe we'll be able to reach those goals.
Yeah, and that's a great sign. That's a great sign that a solid-state lithium-ion battery manufacturer already has you under NDA to try and work something out. I think even if it doesn't work out, that's still a great sign that you're getting serious phone calls.
Yeah, and so basically, high purity silicone metal powder for lithium-ion batteries. We're starting now the testing protocol. So we already have wafers, so they're going to be just silicone metal. You can use mine, you can use the other ones. That's not really the relevance. What you upgrade the value to it. So they're already on their way. I think they've been shipped today to go to our laboratory in Montreal to start testing them. So we're already starting to take a look at this. So in 2020, we'll be ready to send sample to Research Center because they're the one that's going to validate our results and allow us to publish it. They're the true independent valuation. But the other one is going to be being able to send them to end user for product qualification and sales. Because that's going to, it's going to work. You're going to send a product qualification and sales into everything else. Remember, we're supported by 2 world-class technical partners, not Bernard up there. So why invest in HPQ? That's literally what it is. If you believe that the next big thing is energy storage, and the big boys believe in it, HPQ is uniquely positioned to do into it. And
well,
we don't have
believe in that the future is going to be, energy storage. There's no doubting that. And, I'm glad we had this presentation because there are so many Me Too companies out there claiming that they are it. But it's hard to argue with what you're putting out here that silicon specifically is going to be the metal of the future for the renewable energy market.
Yeah, people give us time. We'll be upgrading our website to reflect more our battery space. Now it's more solar, but I wanted this deck to be finished, and took a bit of time to get all the ideas correctly there. But I think it flows well. I think it explains very well everything that we've been doing, and it's based on, we've been working at this since 2016. So it's not we're not coming out of the blue. You can go back.
For people that are watching at home, listening on their podcast, remember, there's a lot to absorb here. So what you should do is go back. You've already heard Bernard, go beyond the deck here, but you may want to go back and review the actual deck itself, read it again, let it really sink in. And then there's no doubt you're going to have a lot of questions because there's a lot, this is new, this is groundbreaking science here, right? At the end of the day. So make sure you get into the HPQ hub on Agoracom and post your questions there because, Bernard is actually verified. So when you're asking questions, you're getting answers from Bernard. That's actually him. And that kind of access and that kind of transparency, I think, speaks volumes on its own.
Yeah. And the last point is our share, basically management, PYROGENESIS, the Quebec government, strategic investors, and key investors. We own a significant stake into this on a fully diluted basis. What that really means is, although we have 62 million warrants out there, I think 71% are controlled by 4 groups. So it's not going to be wildly done. So I think we represent a really unique investment opportunity. I think people should take a look at it.
Well, Bernard, you definitely make a compelling case. There's no doubt about it. And the fact that you're so close to, it's right there on the slide, to start commercializing, the fact that you're already under NDA with the solid state lithium ion battery manufacturer, you're about to send samples to research centers to independently validate what you've been telling the world, I think is pretty compelling for everyone at home. So I hope you've given everyone a lot to think about. You've given some great due diligence here. And as always, thank you for joining us today because, you're Netflix for Agoracom now. You've got a new episode coming out, every 10 days for HPQ, something new. And this is really, really exciting. So thanks for joining us today. Much appreciated.
You're welcome.
You've been watching Bernard Tourniol, HPQ Silicon Resources CEO. The company trades on the venture exchange under the stock symbol HPQ. You've heard what he had to say. You've watched what he had to say. Now you've got to do your part of the due diligence. Get to Agoracom, read the profile information, get caught up on HPQ, watch a couple of previous interviews as well. Those are very helpful. Then get over to the company's site. From what Bernard said earlier, it's going to be brand new and upgraded now that they've got this deck done. And then lastly, when you've got your questions, get to the forum on Agoracom, post your questions, get your answers, because you want to hear it straight from the horse's mouth, and Bernard is there for you. Thanks for joining us, everyone. Have a fantastic day. We'll see you next time.